To begin calibrating the pH meter, remove the electrode from the wash bottle. Wash it with distilled water upon a waste beaker. Click on the red bar that displays the pH number. 0 the number, and then press Calibrate. Once you appear to the blue screen, press Calibrate now. In this experiment, we will be using pH 7 buffer and pH 4 buffer. First, place the electrode into the pH 7 buffer, wait for the numbers of voltage to stabilize, enter the number 7 for pH, and press Keep. Remove the electrode from the buffer and wash with distilled water upon a waste beaker. Then, you may place the electrode into the pH 4 buffer. As before, wait for the numbers of voltage to stabilize and then enter 4. Press Keep, and since you are now finished, you may press OK. The pH meter should read something similar to the buffer you have had it in. When using the electrode on other solutions, make sure to always wash it with distilled water to rinse away that solution. You may now use the pH meter to read the pH of other solutions, including apple juice, orange juice, and acetic acid. You may now record these pH readings into your lab notebook for further use. When finished with the pH meter, make sure to wash it with distilled water and place it back into its cap. After use, make sure to clean up your workspace and return the pH meter back to your TA. And now Jelecia will explain some key concepts concerning this lab.
The difference between a strong acid and a weak acid is that a strong acid disassociates completely while a weak acid doesn't. This affects the equilibrium in this way. Because a strong acid disassociates completely, the concentration of the acid is equal to the concentration of hydronium. In addition to this, the conjugate base is weaker than water. Because of this, equilibrium is reached and the concentration of each side is equal. However, in a weak acid, the acid does not dissociate completely. And the conjugate base is less basic than the water. It's also unstable. Because of this, a reverse reaction occurs. And because a reverse reaction occurs, at the end of the equation, there's more weak acid than the concentration of the weak acid is higher than the concentration of hydronium.
A buffer contains both an acid and a base, so that it's readily able to accept a strong acid or a strong base. The way that works is when a strong acid is added to the buffer, it reacts to the weak base that the buffer already contains. In this case, it becomes a weak acid. When a strong base is added to the buffer, it reacts with the weak acid that the buffer already contains and becomes a weak base. In this way, the buffer resists pH change and it maintains the equilibrium in the acid-base ratio.